Hi everybody, and welcome to next preview lecture from IP Expert. Today I would like to talk about deploying remote access VPN, which we will terminate on the ASA firewall. So I would like to show you the configuration, but before we get to the CLI, because this is going to be the method I will use to configure a tunnel, I would like to talk about the different building blocks we need to define for a successful implementation of a solution like that. So my recommendation, as always, is to follow the negotiation that is performed between the VPN devices. Try to think like a VPN gateway. What kind of elements do I need to have in place so my phase 1 connection is built? Now, when I have my phase 1 tunnel built, what is going to be a subsequent negotiation that will be performed within this management tunnel? So in case of remote access, with, in this case, IKV1, this is going to be an EasyVPN implementation. So we will be using the legacy protocol for negotiation of management session, IKE version 1. There is going to be a so-called phase 1.5, which follows phase 1 negotiation. And then when this is finished, we will move on to the second negotiation to derive policy for our IPsec essays. So let's think, what do we need to define for phase 1? Well, I definitely want to define my policy. So the encryption hashing functions that we will use to protect the management session. And this also includes the Diffie-Hellman group number. Now, another thing that is kind of like specific to the ASA, well, we still need to define our authentication credentials. This can be either a pre-shared key, or if RSA signatures are used for authentication, we would need to specify a trust point. And this information is configured under a tunnel group. So tunnel group on the ASA is used to terminate incoming sessions. It is going to be selected based on some certain criteria. You can have multiple tunnel groups defined for multiple sessions, and this tunnel group is going to define settings shared for all connections terminating on this particular tunnel group. So these are going to be the settings for the connection itself, where probably the most important setting is a so-called group policy, which in turn defines attributes for our users and also for the session itself. Okay, so a tunnel group, this is going to be needed so I can define my pre-shared key, because we will be using pre-shared keys for authentication. Now, when phase 1 is finished, we've got our management connection up and working. What's going to follow? This is going to be phase 1.5. What do I need over here? There is going to be a so-called extended authentication, which is a process of authenticating our connecting user. So there will be two types of authentications involved in the tunnel establishment. One is to authenticate the device, which happens over here, and the other one is to authenticate the user, which is that portion. Now, I need to define well, of course, the extended authentication is optional. You could technically disable it, but we will use this stage. So I am supposed to define a AAA server, or just a database, which is gonna contain the information about the users, valid users, and their password. So this element is also defined under a tunnel group, which means that this element, the tunnel group, this is actually shared between the phases. So when you think about a tunnel group, remember that it is used in phase 1, but also in phase 1.5. Okay, there is going to be a so-called mode configuration and then reverse route injection that is going to follow. Mode configuration is going to be defined by our group policy. So another element I need to define is the group policy, and I can specify things such as an address pool. So we will be assigning an IP address to the connecting client. I have an option to define my split tunneling policy. This will be either a policy, and also optionally, if you have selected the tunnel specified method, you will be also able to define a split tunneling access list, which defines the subnets that you want to have reachable through the tunnel for the client. So the traffic that we want to encrypt, we want to send through the tunnel. You can also define some other options such as a VPN filter, maybe restrict the protocols used for connection, such as this group policy can be only used when IGV1 was used for negotiation, or maybe IGV2. In our case, I'm going to leave this setting. It's going to allow IGV1 automatically. And then phase 2 is going to follow. No special consideration for this step. ASA is going to insert a static route to the table automatically. But for phase 2, I still need to define my policy. So a transform set. I need to specify, I need to create a so-called dynamic map. Then this map is going to be bound to a static map. And finally, static map is going to be finally assigned to the physical port. So this one is going to go to the interface. Okay, I will also need to enable IGV1 on my interface. I would also check in the configuration what is the policy for assigning addresses to the connecting clients. We can either use DHCP, AAA, or a local database. So I want to make sure that local database option is enabled because I will be defining my pool locally. And once those different blocks are defined, we can start testing our configuration. Okay, the topology that I will be using in this recording is really simple. We have a workstation that is connected to a cloud that emulates internet. And this guy is going to be coming from, the session is going to be coming from 74.1.5.200. I will be using a software VPN client installed on this PC. The internet is connected to the indirectly. We will have a router in between. It is connected to the ASA. And this device will obviously terminate the session. And ASA is connected to the corporate cloud with those subnets being used. 10.24.0/16 and 172.16.41.0/24. So these two are our split tunneling subnets. So in other words, when the tunnel is built and terminates on the ASA, whenever the PC has a packet to be sent to one of these two, this or that, this traffic is going to be sent through the tunnel. Now everything else goes in clear to the internet. Right, so let's take a look at this on the CLI. So if you go, maybe just let's open up the list over here. Phase 1 policy. Crypto ID1 policy, say number 10. Specify the authentication method, encryption, hashing, and the Diffie-Hellman group. Now, one important thing to remember here when you build a policy for remote access sessions specifically is that Cisco VPN client, software client I will be using, it only supports certain combinations of policies. And if you go for triple DS encryption, which is what I will do, you will not be able to successfully negotiate a tunnel when you specify group number 5 for Diffie-Hellman. So we need to go for group number 2. That's the one that is supported with triple DS as the for encryption. Then let's go MD5 for hashing. I've got my policy. Now I need to define my tunnel group. So tunnel group. Now the name is going to be important because it has to match what you configure on the client. The VPN group configured on the software client. So I will call it home office. Like for our employees who work from home, for the teleworkers, those connections are supposed to terminate on that tunnel group. Type is going to be remote access. You don't want to go for this option. Note that it is deprecated. So type is remote access. Now I need to specify 2 sets of attributes. IPsec is what I need for phase 1. So let's go ahead and do this. This is where I can specify my pre-short key. Let's go for Cisco 123. Something simple. Then another set of attributes is going to be defined under the general attribute set. And this is where I can specify my group policy. So obviously, so I can specify my group policy, I need to first define it. So let's do this. Let's call it home policy. It's going to be defined internally on the ASA, and the attributes, well, at minimum, I need to define an address pool. You can technically specify an address pool under a tunnel group as well. Then the one specified in the group policy is going to take precedence. You can only specify in the address pool under the group policy. You can only specify it under a tunnel group. In our case, I'm going to specify a pool under the group policy because the group policy is going to be still called out from within a tunnel group. The one place is always enough for the address pool. And then we will also configure our split tunneling list and policy, because the policy is going to be set to tunnel specified, and list is going to define what we want to specify for what goes through the tunnel. You could also restrict the tunnel protocol, maybe apply a filter to control the traffic flowing through the tunnel. We will not be dealing with these options. Let's just define a pool, H pool, as for home, 10, 100, 100, 1 through 10, 100, 100, 254. Now don't forget about the mask option, because if you don't specify mask implicitly, it is going to assume the natural network mask of the pool, which in our case, this is class A network 10. It would assume a network mask of /8. I want to use /24, so I need to specify it. Okay, I've got my pool I need to define an access list for split tunneling. Now let's call it split. And the subnets we will be using, these are those networks, 172.16.41 and 1024/16. So they all go to a single access list. And now let's go back to my group policy and activate those options. So under attributes, address pool is this one. I need to say value. Then my split tunneling, the policy is gonna be tunnel specified. So whatever my access list permits is gonna be sent for the tunnel. The default option is tunnel all. Right, so this is my policy. Now the network list, I called it split. This is what I need for my group policy. We need to go back to the tunnel group and activate the policy under general attributes. Default group policy is HP. What was the name of the policy? Home policy. Now another thing that you can specify under a tunnel group, the general attributes, is a location of the database that you will use to authenticate your users. The default option is authentication-server-group, this command. And the default setting is local, which means that we will use a local database, locally defined users for authentication. So I need to add one, Cisco password, Cisco. I will be authenticating as Cisco. Now my database is now not empty, and this covers phase 1 and phase 1.5 configuration. So this is what we have so far. Say show run crypto. I've got my phase 1 policy. Then I have my group policy defined, which specifies what are the attributes we will be pushing to the connecting client doing mode configuration stage of phase 1.5. And this group policy is also activated under my tunnel group. And this is also where I have specified my pre-cert key. So phase 1.5 is fully covered. Now we can move on to the second phase. Crypto IPsec IV1 transform set. Set my cryptographic functions to protect IPsec packets to use the functions in the under IPsec assays which protect the data plane. EES ESP EES and then say MD5. Okay, I said we also need to define a dynamic map. Now, note that you don't define an access list, your encryption domain, because your encryption domain is going to be defined by the split tunneling policy and an IP address that you assign to the client. So no access list needed for the encryption domain. Crypto dynamic map, DMAP as the name. Entry number 10, set my transform set, which was set 1. Okay, it was called set. So run crypto. Let's make sure that it took the command, which it did. Then my static map, Let's call it S map. Now give it some high number for the entry. Dynamic map is always supposed to be bound at the end of the static map so it doesn't interfere with your site-to-site connections. Let's go for 1000 and then the name of the map, dmap. Now this static map must be still applied to the physical port. In our case, to the outside. I need to enable the ISA camp on the outside. And ideally, as I said previously, I would also make sure that the address assignment is enabled for the locally defined pools. It looks like the default options are being used, which also includes locally defined address pools. So this command, you want to have it in place if you want to assign address from a local pool. Right, so this is it. Now, there is a command, before we start testing this, I would like to show you one more command that you can technically use to figure out the steps you need to take to implement a solution, remote access solution on the ASA from the command line. The command is VPN setup with the IPsec remote access keyword and then steps. It basically tells you about those different building blocks, not all of them, but about, I would say, a vast majority of the elements that you need to define to get this up and working, assuming that you don't want to use some of the default locally defined groups. So it says, initialize the interfaces, create your ISACAM policy, define a local pool, specify the authentication database. In this case, it wants to use Radius for communication with a AAA server, which is this IP address. This is going to be the key that will protect Radius communication. In our case, this was not needed because, once again, I will be using local database to authenticate the users. Then it says define a tunnel group, which in this case is called client. Specify general attributes, address pool, and authentication server, and then the key. Now, note that it didn't say anything about the group policy, which means that it will be using a default group policy. Then phase 2, transform set, dynamic map, static map, apply, enable ISACAM. So almost all steps we have taken, and they are shown. You can see them with this command. Okay, let's say show run crypto and take a look at phase 2 configuration. So we have our transform set, dynamic map, static map is bound to the dynamic map and then applied to the outside. This looks good. Let's go to the test PC. I'll give it a second. I need to first connect to the PC. Apparently I have lost connectivity previously. So I will be trying to reach two devices, one in this subnet and then another one under 10.24.00/16. Okay, so first thing, let's define a connection profile for our ASA. It uses 172.141.30 on the outside. Then my VPN group name, this must match my tunnel group. So it must be called home office. Password is Cisco123, what I set for the pre-shared key. Well, let's save and try to connect. Okay, let me quickly check the IP address of the ASA. One 172.1.1.1.4.30. Okay, it's actually 114. Let's modify. Okay, let's see if I can reach this device. 172.1.1.1.4.30. Say ipconfig 74.15200. Say route print. Okay, looks like I don't have a route to this subnet. Let's say route add 172.1.1.1.4 74.1.4.54. Okay, so now I have IP reachability between the client and the ASA. Let's give it another try. And we see that this time I'm getting the authentication prompt. This is for the user. Cisco. So let's try to authenticate, and apparently the session was established. I can take a look at the client statistics. We see that this is an IP address we were assigned, 10.100.101. This is the real IP address of the ASA, the IP address of the ASA, I should say. And then the split tunneling policy under secured routes. This is what the ASA pushed to the client. So ASA told the client that your traffic sent to those subnets will be actually sent through the tunnel. So I should be able to test it. Let's say ping 1024. Was it 7 or 9? Say 7. Okay, so at least we see that it sends the packets through the tunnel. The counters under encrypted are increasing. Let's try to reach 172. What was the other one? 1641. 1641, 7. 9. Okay, this must be a problem with my. Okay, it says deny inbound. This is a problem with the ASA configuration, with the initial configuration of the ASA. Okay, name if outside, let's say showed on interface. Say this is supposed to be inside. Okay, this guy is called inside and security is 100. The problem was that we had the situation we had was that the inside interface was set with a security level of 0, which is the same as our outside. So when the traffic is coming back from the clients, it is blocked based on the default filtering behavior of the ASA, which is to drop the packets between the interfaces configured with the same security level. This should be fixed now. We see I can reach 172.1641.9, and I should be also able to reach 1024 subnet. So we see that this is the case. The count is increasing under both encryption and decryption, and I could also verify this on the ASA. And probably the best command you can use is show VPN session with the detail option for remote access IB1 connections. So first thing, it tells you about the tunnel in general, gives you some general information about the tunnel. This is my extended authentication user, the group policy that was assigned, and then the tunnel group that was matched. Some phase 1 information about the algorithms, and then phase 2 counters. And then you have more detailed information for individual phases. So phase 1 and then phase 2. But the bottom line is that we see that the packets increase. The ASA is getting the packets, is decrypting them, and then encrypting back the replies from our internal devices. Right, at the end, as usually I like to mention about some other sources of free training from IP Expert. You can find us on YouTube or our blog. If you want to find out about some promotions or the upcoming changes to the products, maybe new products coming out, you can visit us on our website, Facebook, or follow us on Twitter. If you have any questions to this session, I will be online for the next 10 minutes. You can also shoot me an email at paotrk@ipexpert.com. Thank you for watching.